let me write down all the information. They said that they did 50 joules of work. They said that the distance that it was moved, the horizontal distance, was 10 meters. And then they asked us what force did they have to apply to make that happen. So you have a person, well, you have a perfectly horizontal plane, and then you have an object. We don't know what the mass of the object is, it didn't really say. But then you have a person that did 50 joules of work to displace this thing 10 meters. And they want to know how much force did they apply to make all that happen. Okay? So what do we know? We know the work, we know the distance, and we know the force. So the first thing that I want to do is I want to draw the picture. So let's kind of review that a little bit. First thing, we want to draw the picture. Second thing I want to do is list what I know. And then the third thing is I want to figure out what I need to know. Okay? That's N2K, right? Need to know. And then next thing I want to do is write down an equation that maybe shows the relationships. So in your textbook, we say that work is equal to the force times a distance. So work is nothing more than applying a force on something, having it move a distance. Okay? And then what we're really interested in is we want to know what the force is. So now I can algebraically divide both sides by the distance, and I get that the force is equal to the work divided by the distance. Now there's another formula in your textbook, okay, that says that the work is equal to the magnitude of the force times cosine of theta times the distance. And that's if we have, like if they're pulling on a rope and there's some angle. If a person does 50 joules of work moving a box that's 30 kilograms. Oh, I guess they do give us that. 30 kilograms. That's 30 kilograms over a distance of 10 meters on a horizontal surface. What is the minimum force required? Well, it doesn't say if he's pulling or pushing, and it doesn't give us an angle. So what angle could we assume?
There is no angle.
Yeah, so you guys are saying the right thing. So the angle would be like, if he was pulling it, this would be theta, right? Now remember, theta is a Greek letter. It's like A, B, C, D. We use this Greek letter because, I don't know, it's because the people that kind of made geometry popular were Greek, and they used this letter.
What letter is theta?
Theta, it's like TH, okay? But we're assuming that this guy didn't pull or push at an angle, so we could say that the angle theta is equal to 0. By the way, what's cosine of 0? Do it in your calculator real quick.
1.
It's 1. So we end up with this formula anyways, okay? If we make that assumption. Why did I show you that? We don't need it for problem number 1, but for some of the other ones, they'll give you an angle for theta, and we go from there, okay? All right, so now I just need to plug my numbers in and see what I get. So now that I've picked out my equation, I need to solve. So what I'm going to do is I'm going to say the force should equal 50 joules of work over 10 meters, and that should be 5 newtons of force.